Hi, I'm Tamko, and today I'm gonna quickly explain you what compressor is and how it works. So what does compressor actually do? I will show you it visually, it's very simple. Let's take this area of the signal. We see that it has loud parts and quiet parts. So a compressor would take loud parts, it would make it quieter, and then it would take both of them, loud and quiet, and make it back louder again. So in result, we have quite flat-ish, and loud signal. So we should always remember that compressing is two-step processing. First, you make loud parts quieter, and then you make everything louder. Compressor is not about just making things louder, because for this one we use maximizer. Okay, so let's return everything back. And let's put iZotope Neutron here to see how it actually works. Here we have bell melody. Let's listen to it. It's quite simple, but we see here that it has loud parts and quiet parts. So let's start with threshold. Let's lower down our threshold. Okay, so now our compressor knows that everything that is below threshold is fine, it's normal signal, we should not touch it. And everything that is above threshold is too loud and we should make it quieter. Just that simple. So the next question is, how quiet should I make this signal? Twice or 3 times or 4 times quieter? Ratio is responsible for this one. It means that now our compressor would make everything that is above threshold line 2 times quieter, because ratio is 2 to 1. So if I make it 4, compressor will make everything 4 times quieter. Let's lower down attack to see it clearly. Here you see, in front of us, we have white signal, it's already processed signal. And behind it we have transparent gray signal, it's original input signal. So you see that the difference between is 4 times. Let's make it even more. Let's make it 10. And now you see that signal is almost squashing. Next one, attack. Attack is responsible for how quickly your compressor works, how quickly your compressor reacts. If you set it to almost 0, it means that compressor reacts immediately, like here. Every time we get input signal, compressor immediately decreases the level of our signal. Let's make it bigger and see the shape of this line, how it would change. You see, it became very different. It becomes exponential. And it means that this compressor, it takes 23 milliseconds for it to start fully compressing the signal. The next one is release, and I think that it's much more easier to realize how release works using it on a kick. Here is our kick. Let's lower down threshold. And look at this orange line. Look at the shape of releasing the signal. So we see here that compressor processed the signal very quickly. For 20 milliseconds, we reached full compression. And then we slowly let signal go back for 100 milliseconds. Let's lower down it to almost 0 and to see the shape of this part. You see, it goes back immediately. Let's slowly make it longer and see how its shape of the signal change. You see, it becomes more and more exponential. Yeah, so it takes 142 milliseconds for compressor to completely let compressing go. Okay, so now let's turn off auto gain. And as you can hear, when we compressed our signal, it became quieter. Before and after. So it means that we should give this signal back. For this one, we have makeup. Makeup is output level of already processed signal to return it to the back volume. Before and after. Let's say 7. Do you hear that we lost punch? So let's up our threshold and to lose a bit of release. And lose our attack. Yeah. Before and after. Some compressors, they have more fine-tuning, but I think that for beginners, this is enough.